today. I am John Lagan. With me are
Cynthia Maruku.
Our experiment is conductivity, and the aim is to investigate the conductivity of aqueous solution of some compounds. One of the properties of ionic or electrovalent compound is that they conduct electricity in molten or in aqueous form. In electrovalent compounds such as sodium chloride and calcium chloride, there is an attraction between the metallic cation and non-metallic anion, giving rise to ionic bonding. In covalent compounds such as ammonia, water, and sucrose, there are no charges in them and they cannot conduct electricity in molten or in aqueous solution. I will be handing over to Cynthia to show us the materials needed for the experiment.
Thank you. The materials needed for this experiment are beakers, ammeter, stirrer, spatulas, electrodes, batteries, flexible wires, a measuring cylinder, weighing balance, sodium chloride, calcium chloride, ammonia, sucrose, and distilled water. Lillian will demonstrate the experiment for us.
Thank you. Procedure. Step 1. Fill all the 250 ml beakers with distilled water. These are 6 beakers labeled A, B, C, D, and E. Beaker A is serving as our control containing distilled water. It will be used to calibrate the ammeter. To beaker B, weigh 10 grams of sodium chloride and dissolve it. To beaker C, weigh 10 grams of calcium chloride and dissolve it into the water. To beaker D, measure 10 ml of ammonia and dissolve it into the water. To beaker E, weigh 10 grams of sucrose and dissolve it into the water. To beaker E, weigh 10 grams of sucrose to dissolve it into the water. To beaker E, weigh 10 grams of sucrose and dissolve it into the water. I will now be handing over to Shepherd to take over.
Thank you. First, we connect our ammeter to the battery. The one wire joining the electrode to the battery. Then connect the second wire to the second electrode. Here the ammeter has been connected to the cells and the electrode. First, we insert our electrodes in the beaker A containing distilled water. There's no deflection in the ammeter. This shows that water is a covalent compound. The next is a beaker B contains sodium chloride solution. Here there's deflection in the ammeter. This shows that sodium chloride is an electrovalent compound, which means that it can conduct electricity in aqueous solution. Before testing a sample C, we rinse our electrodes with distilled water. Now this is a beaker C containing calcium chloride solution. There's deflection in the ammeter, which means that calcium chloride is an electrovalent compound, which can conduct electricity in aqueous solution. Rinse the electrode before testing with the next solution. Here is a beaker D containing ammonia solution. Here there's no deflection in the ammeter. This means that ammonia is not an electrovalent compound but a covalent compound, which can not conduct electricity in aqueous solution. Now we rinse the electrode before testing with our last sample. Our last sample here is sucrose solution. There's no deflection in the ammeter, which means that sucrose is a covalent compound and not an electrovalent compound, and it cannot conduct electricity in aqueous solution.
In conclusion, calcium chloride, sodium chloride are electrovalent compounds which conduct electricity in aqueous solution, while distilled water, ammonia, and sucrose are covalent compounds which do not conduct electricity in aqueous form.
Thank you.